Okay, we're back. Right, so what we tried to do here is like pick, you try to just pick a point on this like cost axis from 0 to the cost of the Pareto point. Okay, so now I remember how you do this. Cool. Yeah, so it's back up on X and everywhere else now. Good. I remember a big thing with early dev in Protein was trying to figure out if there were different ways we could weight different environment reward functions. Uh, Basically nothing worked for this, right? What's the focus? Next release? Yeah. So goal is just, we're now going back through all the things that need to be done for the release. We're starting to write some notes here. Protein is going to be the main thing today, all our hyperparam tuning stuff, plus configs, and then we'll see how long that takes. The thing that's just tricky with releases, right, is like the code gets into the state that it gets over several months of dev, and you have to do quite a bit of cleanup, but also that there are some like big experiment sweeps that you need to run before release. And then you actually want to delete the settings that are used in a lot of those experiment sweeps before the release. And the motivation behind that is this is not just like a paper release where you're trying to reproduce the paper, right? Like you can always go back and grab our old commit if you want to do that, or we might just make a branch for it. But we don't want to have bad settings in the release code, right? We want it to just be the one path, like this works the best on everything, use this. So we don't want to give users a whole bunch of confusing settings to like try stuff out themselves. We just want to make it the simplest thing possible. So I have to get the code into a clean state, except for removing those tidbits. I have to comprehensively run all these different experiments, like have that in a good spot. And then I have to figure out like a good way to either, well, I don't have to remove everything to be fair. Like I can leave additional stuff, for instance, for like testing sweeps in the sweep code, but I don't want to have, for instance, I don't want to have like all the different advantage functions living in the main train script. I just want to have the one that we're going to use. Yeah. So that's like the tricky thing. Yeah, so we can remove this inverse score function. And this is now just a linearize, right? Oh, this is unlinearize. Don't you clip rewards? That's separate. So you're not training, the hyperparam sweep algorithm does not necessarily use rewards. And typically it's a bad idea to use just raw rewards. You use like the ultimate score variable that you care about. And this is a big difference because, like, for instance, in neural MMO or in like more complex M's, you might have a whole bunch of different reward components, but you don't want to sweep based on the rewards you see because that's not robust to changes in the coefficients themselves. You want to sweep based on a external metric you care about. So in the case of neural MMO, it's the minimum of your combat and your profession level. So the goal is to level up both of your skills, and that's what we use as the metric for that. In MOBA, there are a bunch of different reward components, but it's just your win rate. So, yeah, we no longer do X transform. You standardize a certain score metric comment. That is separate. So the reason that we did that, it wasn't for this at all. Though interestingly, it might help. Now that I'm thinking about that, that's actually kind of cool. I don't think it should matter that much because it's just a linearizing factor, which carbs does anyways for you. The reason I did that was so that I could plot all the M's on the same plot. So like I could run a benchmark on everything and I could get all the M's on the same plot if I wanted to. That's all. Oh yeah, the one other thing we tried, several versions of. So we also tried Final. What distance metric did you end up using for sampling? I had a similar problem lately using kernel methods, Gaussian processes here, right? And that was a struggle. I ended up doing some screening algorithm and taking the max, the expectation plus some variance metric. That's not great when the reward function isn't super smooth. For hyperparameter tuning specifically, so we found that you don't want to rely on the Gaussian process in any way. Like the variance prediction of the Gaussian process is garbage. The mean is at most directionally correct. You just do not want to use it in any meaningful way for that. So what we do it instead, we try to just like we try to get a cost. We like just generate a cost randomly between 0 and 125% of the max cost that we've seen, or max Pareto cost that we've seen. And then we have a scoring function that attempts to pick hyperparams that we expect will be scoring high and near that cost. That's all we do. So we're really not relying very heavily on the correctness of the Gaussian processes at all, other than being like directionally correct. Basically, every single thing that I tried that it like relied on those models, the Gaussian processes, in like any meaningful way would lead to shitty edge cases where like the predictions would end up being wrong, and then you would just stop exploring because of it. So protein is, in a sense, it's a very simple algorithm compared to like to carbs or stuff, but it's very, very robust in the sense that like it can't screw up in the way that a lot of these more complex algorithms that rely on the Gaussian processes more heavily can screw up. Like there was all sorts of cool stuff that I tried to do earlier on. I had this really cool version that was like a binary search that fills out the Pareto frontier. So like you're like trying to fill in points that are halfway between like the farthest two Pareto points. You get like a very efficient filling out of the frontier. But like as soon as one prediction is wrong, you're totally screwed doing that. Like anything that relies, like you can't rely on adjacent points for very much to be completely correct because they can be noisy. You kind of can't rely on anything fully doing hyperparam tuning, which is tough. 125% cost is a robust but kind of forcing it to explore. The idea is that so like 20% of the time or whatever, you're just going to end up sampling a higher cost point than your highest cost Pareto. But that point, like, it's not going to push you to explore even higher cost unless it ends up being Pareto. And you can tune that factor. We have it hard coded now, but you can tune that factor to be like more or less aggressive. It's kind of random exploration. It's not random exploration. Thank you, Captain. This is. Hang on. Let me just show you. Let me just show you this crazy setup I'm working with here. Don't think I'm leaking anything here, right? Nah, we're good. I had to tune the camera params a little bit, and I don't know what I'm doing in that space. But yeah, this is this is what I'm looking at here. So Boxen, it's not random exploration, because you're still using the Gaussian process. What happens is you sample between 1 and 125% of a cost, okay, but you still need to get a point. You still need to select hyperparams that you expect to get there. So what you do is you generate, I believe around the Pareto points, right? You generate a whole bunch of candidates, like that are like going randomly sampled from around the Pareto points, and then you score them using the Gaussian processes, and you use the predicted cost and score to select which point that you attempt to get that you expect to be near in cost. So you're still relying on these, but you're relying on them way less directly, in a way that is, there are like way fewer ways for things to go wrong. Oh yeah, I have good view. It's actually, oh man, it's like raining a whole bunch today. I got a good 6 mile run in torrential rain yesterday. I don't really need to run again today, but I do enjoy running in. I like running in torrential downpour. It's honestly easier running in like, it's just honestly it's easier. You just don't overheat. I'm just working on like cleaning up and documenting everything, Captain, because like we're trying to work towards the release. Speaking of which, we definitely want to get Impulse Wars into a good spot. We want all the new M's in a good spot for that. Um, but like there's just a bunch of cleanup work here. Let me show you what I did already. So this is clean PufferL with the demo file included now. It's all one file. 1169 lines. It's actually less than 1,000 lines of code for all the demo. I've managed to get it down quite a bit in lines, and I think we're going to get it down, another 100 or 200 before we release this. But I'm trying to release, like, you can just solve everything with a script. Started on moving impulse wars to new bindings. What are you binding it with? Oh, instead of Scython, you mean? Why isn't it easy? The new bindings are supposed to be pretty straightforward. Like, you shouldn't have to touch the env binding at all. You should be able to just do the thing that neural MMO is. It's C values into Python. We should have that. Let me think. Do we not have that? Hmm. We might not. I can add stuff with that, though. What do you need the constants for, anyways? It's just a bunch of constants, right? Or are there, like, shared data buffers that you need? Taking an env and return a dict. Like, what do you need from the env, though? I know you have, like, the automatic whatever, like, network size definition that's just, like, loaded from a bunch of constants. My recommendation there would just to be to card code the net size. Like, having 30 lines of whatever to, like, automate the network definition size, I don't think really helps you. Because you're basically, like, it's unreadable anyways, so you may as well just use the lazy layers if you want it to be, like, automatic. Or you hard code it if you don't want the lazy layers to bite you, which is what I do. Helps me. And you have to change it. Then use the lazy layer if you want to do that. Like, the point of me hard coding network sizes is so that I don't accidentally end up with ridiculously sized layers. If you just want it to work, you can just use the lazy layers. I don't think, like, having 30 lines of unreadable code to compute sizes is just the worst of both. Because, like, you still can't tell by looking at it what the network output sizes are going to be, and you have 30 lines of garbage, and you need now to access all those constants. I do some calculations of obs offsets in C. Yeah, I just duplicate. I mean, I just duplicate it because it's like a couple lines of code, or not even. It's like a couple of constants or whatever, and it's like way worse to add all the logic to like get that information up to the model. You can have named variables and like and still just set them. Like, technically, I guess you could get it. I mean, here, if you want to do it that way though, right? Like, why can't you just declare the constant in a Python and pass it to C on init? Then it's going to be available either way. Isn't that like way easier than like defining it in the C and then having to like pull it back? Then the only place you'd have to duplicate it is in like the .c demo file, which who cares? That's no big deal. And you might even want it to be different there anyways. Because like that demo file, yeah, you might want that different there anyways. Okay, so that's all of these extra comments gotten out. Oh, no, we still have these. The question's like, why are there 24 obs constants? Wait, like having 24 obs constants, there's just no way that you're going to be able to make that clean, even if you can get the params from C, because then you're doing some calculations on a dozen constants in the frickin' Python, right? Like in the model when you init that. So I'm gonna have to look at it. I think either way. We also have carbs here. All right. Okay, so I just basically deleted a bunch of comments and added some notes. The tricky thing here is I don't want to test this fully until everything else is stable. Maybe I should just start doing it, though. Man, it's like so obnoxious. It's like really difficult when I can't just finish the sweeps or finish this or finish that because like everything depends on everything else. This is at least cleaner for now. We're gonna have to keep this in. This will be like a plot function, I'm sure, when we go to do the experiments. 684 lines. I think we update all the configs now. So it's sweep, goal, maximize. So actually none of these need sweep blocks anymore, I think. Are you also going to do a full cleanup of the rest of the code base? Are you going to keep puffer Atari file. Unused functions. I'm gonna clean it up iteratively and see what gets kept and what doesn't. So we're gonna see. I wish the default ISO on this thing were better. Or the auto ISO. Okay. Got this. When you say the puffer Atari file, you mean like the cleanRL demo for comparison? I don't know. Maybe not. We'll see. I might. It's like, it's still useful to see. I might keep just like that one file. I'm probably not going to keep any of the SB3 stuff, because like at this point, if you're using SB3, you're just hard trolling anyways. I don't know. I've become a lot less tolerant, I think, of people who just like, oh, but can we make it work with the thing that we're already using, even if the thing we're already using sucks? Like CleanRL, it's like, okay, you want a simple thing that you can use to like test, like fine, right? CleanRL is actually good. It's just slow. All right. So that should have this at least runnable on stuff. Runs. Opinions about policy constants aside, if I had some way to pass values from C to Python, I could have migrated, I could have it migrated pretty easily. Let me think how the hell we do that. Yeah, you know, I can do it. I can do it pretty easily for you. You literally would just need like a get function or whatever. I could just define like put and get, yeah. Yeah, that's literally what it would be, Captain. It took me a second to like remember how I did stuff and how I could do that relatively simply. So it just mirrors the camera quality, just keep getting like worse and worse as it gets brighter. Yeah. It's like, okay, I'm gonna have to figure something out about this over the day so I don't have to keep doing this. To be fair, it'll be a lot easier with the new lighting. Literally a freaking spider here that's like knit an entire web under my monitor. That will likely be, that type of thing will stop happening once all the maintenance is done around here. It's ridiculous. That is not linky. I gotta get the policy working in C. Man, I just need to spend some time doing some work on impulse force, seeing if I can just get something that's better and simpler for you. Like for all the M's. Okay, so configs are cleaned up. That didn't take very long. Got like 40 minutes now. I gotta figure out a way that I'm going to like actually get to the point where I can run all the final experiments here. First of all, did my sweep finish? I might have 2 boxes free right now. Maybe that's what it is. Maybe it's just like I need to really just have these jobs queued up and like, because the more jobs that start working, the more confident I'm gonna get on this. No, E3B is gonna be deleted. Diane's coming out temporarily, even though Diane I think is actually promising. P3O is coming out even though it's promising. Like, it's just going to be the code path that works, that solves everything. Simple as possible. Puffer Advantage is left in because Puffer Advantage should be on by default. Okay. Yeah, I've kind of just realized, you know what? I'm like, as far as I've gotten away from academia and the way they do things, I need to keep going. It's like things just need to be done the way that I know that they need to be done. And like, and I need to spend less time worrying about like academic naysaying. Okay, look at that. That is over 6.0. That is new soda, and actually by a good margin. It is with a substantially larger policy, but it is good to see that that actually scales. That's pretty darn good. So here's what we're going to do with that. I should. We can actually do that right now. The env hasn't changed though, so it's not like I could have broken the env. Oops. I actually don't think that this is going to load on the current branch. So let me do a couple quick things. Yeah, we have a few things to do actually. Perfect. This is just going to be the right amount of time. Where's Torch? I don't know what I did. That'll work. Okay. So now I think what we do, the order of operations here, we're gonna have to run some sweeps. What M's do we want to use for sweeps? I like the idea of using breakout. That's like a classic speed run. And then we want one that's a bit larger. Maybe we do our maze env. Maze env would be good to resweep. I don't think it takes that long either. So this is 50 mil to 200 mil. $300 mil. And then let's see. The problem is we can't really sweep. There are restrictions now with the sweeps, aren't there? Let's just make sure that everything that's in here is to be in here. I don't think there is any such param as horizon. No. We'll spend some time before releasing get box 2D archives generated. We can use that would be nice. So actually, Captain, I have no idea what the hell we do about the build stuff for release. It's actually quite difficult. Because now we also have CUDA in here. So like I think we have to ship wheels. I don't know if you can ship I don't know, can you ship wheels that like are technically gonna do the Python from source and only the CUDA shipped as like I don't know. I think that there's gonna have to be some sort of obnoxious CI build wheel system or whatever anyways. Like, I definitely want it to be easy to set up if you just, like, when you clone it and minimal. But I think that probably we're gonna have to, like, build a bunch of wheels anyways at this point. I don't know if that affects anything that you're thinking about. Whole bunch of divisibility issues, don't we? Okay, let me think how we do this. What if we don't sweep the number of m's? Okay, that's good. I mean, I'm here for the next few weeks just doing this type of stuff. So as soon as I get like the rest of the code into a decent spot, I'm gonna start looking at fixing, making all the M's work well, and then packaging. Also, did Spencer send me? Is there any reason to make BPT Horizon a hyperparam? I can probably just set it. Because we have new constraints. Like the new experience buffer is a little bit more locked in, like to what combinations of parameters you can have. No, there would still be a reason to have it because if the batch size gets really big, then you're gonna have an issue. But you can't have everything now. I have to figure out a way to do this sweep where all combinations are gonna be valid. I don't want to have like this invalid thing, just reject this trial bullshit. I could just remove it from sweeps for now. Here, this is what we'll do. We'll remove it from sweeps. Yeah, I think this does it. Okay, so auto horizon. Break out at 3 million steps per second. Yup. That's good. And still optimizes. Perfect. So now all I have to be careful with is batch and mini batch. Mini batch is allowed to be this can get really quite large. Well, I guess what's like the lowest that we would entertain? I'm not going to be super surprised if this doesn't perform amazingly. Should be good on a wall clock, though. Okay, so if we're going to do it like this then, right, then there's no reason to have... What is the new approach that removes the need for Python? If you just check out the dev branch, dev or release, either of those, we have this nice env binding. So this is like a 500-line Python API file that just defines a few convenient functions for us. And then, if I look like at this, neural MMO3, this is your entire binding file. All you need to do is you need to tell it what arguments come from Python, unpack those, and what arguments or what log items you want returned. And other than that, it's just going to instantiate these in C using the Python C API. It comes with a vec init, it comes with like a non-vectorized init. It's all in that one file. Now the Python C API is kind of a pain in the ass. It's kind of gross to read, but the key is that each new environment now just needs something like this. It's way easier. And this is still not like a config file. You can still write whatever code you want in here. Like we're gonna add a put function. We're gonna add a get function for like impulse wars because Captain needed something. So it's still pretty easy to do stuff like that with. But like this will cover almost everything. And then if you look at how nice it is to use, so I'm making all these m's in a loop like this, and then I just call vectorize on them, and they just go into one C pointer. It was very convenient. All right, I gotta get cranking here. I got like 10 minutes, and then I'm going for breakfast, so I want to at least get some experiments running. QE7 is 20 mil. 1E8 is 100 mil. The 5E7 scale is auto. Like that. Looks good. Let's see if we can get this to run. And then we will have let's just try it on this box real quick so I have time. That's annoying. Oh, this is just CUDA. Okay. This is just CUDA being annoying. Jeez. I think we can hack it for now. How the hell are there 100 compilation errors? What the hell? Okay, you know what? Screw it. We'll do it on the local machine. That way we at least have a sweep run over breakfast. And then I'll have to fix this build stuff when I get back. This is ridiculous. Welcome to piebind sucking. I do not see this on here at all. That is not good. It's here just without the tag. Okay. Fix the tag. How the heck is there no tag? Oh, I see. We'll just add it here for now. Okay. This is now running. And we should actually see. Yes. We actually do see it here. I will be running for breakfast in a few. I'm just going to make sure that this is correctly running. And the goal here is that this should run a bunch of experiments over the next hour or so. They're not that long. They're only like a minute each at the moment. And we should get at least a good idea of what the current algorithm can do. We'll do a few more of these. I have to get the other boxes set up with the new code to run this. And we should get a pretty good idea of whether this is all working as expected, and that'll give me confidence to go run the final experiments when they need to. Yeah, that's going to be the main idea. And it does seem like these are running correctly, which is good. This is just eval here, so the train stops right here. This is our current best model, is 80 mil solve in, whoops. Okay, well that's bad. Huh. This is going to take more time today, unfortunately, it looks like. It's definitely unstable. Because I've gotten this before as well. See, if you get an infer and nan in here, it breaks. Okay, well, I'm gonna go for breakfast. I will come back after this. Whole bunch of infra to fix, but I think that that'll be a good goal for today is to get like a clean set of sweeps running, so that we can have that portion benchmarked. But for folks watching, puffer.ai for all the things. Go to the GitHub to help me out. It's free. And you can join the Discord to get involved with development. So thanks, and I will be back after breakfast and some exercise. Probably a couple hours.